Okay, this video corresponds with lesson 4.8 from your book, and lesson 4.8 is about Cramer's rule and augmented matrices. So we're going to first talk about how to solve systems of equations with a rule called Cramer's rule. And what Cramer's rule says is if you have something in this form, you can write out the determinant, the coefficient determinant. 3, 2, 1, negative 1. This is the coefficient determinant. And you could, this is the coefficient matrix. You can find the determinant of this, okay, which an easier way to determinant just means vertical bars around it. So if I want to find the determinant of that, I do 3 times negative 1 minus 2 times 1, which is equal to negative 3 minus 2, or negative 5. So the determinant, or what we'll call D in this case, for the coefficient matrix is negative 5. So that's the first step in using Cramer's rule. The next step is that you replace one of the columns. So we'll call this the X column and this the Y column. You replace one of the columns with the constant matrix right here, 0, negative 5. So we're going to put these in for the x values to find what he calls dx. So let's find dx next. dx. So we're going to take these two values and we're going to replace the x values with those two, with the constant matrix. And we're going to find the determinant of that. 0 times negative 1 is 0 minus 2 times negative 5. That's going to be 0 minus or plus 10, which is equal to 10. So dx is equal to 10. And then you can find dy in a similar way. So let me erase this and put back the x values, 3, 1. Okay, so to find dy, you erase the y values and you replace them with the constant matrix, 0, negative 5. And we find the determinant of that. 3 times negative 5 minus 0 times 1 is equal to negative 15 minus 0, or negative 15. So dy is equal to negative 15. So why did we do all this? Why did we find the determinant and dx and dy? Well, it turns out that the x value for this system of equation, or all systems of equations, is equal to dx divided by d. And the y value is equal to dy divided by d. So in this case, dx is 10 and d is negative 5. dy is negative 15 and d is negative 5, which means x equals negative 2 and y equals 3. Those are the solutions to our system of equations. Now let's see if it works. Negative 2, 3. 3 times negative 2 plus 2 times 3 is negative 6 plus 6, which does equal 0. It works in the first one. Let's see if negative 2 minus 3 equals negative 5. It does. So negative 2, 3 is the solution to our equation, and that's Cramer's rule. So I want you to go ahead and pause the video and try and use Cramer's rule on this. Alright, so this is the solution that you should have gotten. If not, you'll want to watch that extra help video where I'll work out that problem and this one. Let's go ahead and use Cramer's rule with a 3 by 3 matrix, but let's just find x. This is where Cramer's rule is really useful. So to find x, we need to find dx over d. We don't need to solve for all of them, so it's going to make this calculation a little bit easier. Let's write our coefficient matrix. X, the first x value is 0, then the first y value is 1, and the first z value is 4. And then x, y, z are all 1 in the next one, and then 2, negative 5, 0. So this is our coefficient matrix. Let's find the determinant. This row is 0, because it has a 0 in it. The next row will be 1 times 2, because it hooks around, will be 2. And then the next row will be 4 times 1 times 5. So 4 times 1 is 4, times negative 5 is negative 20. So that's our first one, which is equal to negative 18. Now let's find the bottom one. Let's go the other way. 4 times 1 times 2 is 8, plus 1 times negative 5 times 0 is 0, plus 0 times anything is 0. So we're going to subtract these two from each other. So this is negative 18 minus 8, which is negative 26. So that's the D value. We found negative 26. Now let's come back in here and write the exact same matrix and replace the X column. So here's that same matrix again, 0, 1, 4, 1, 1, 1, 2, negative 5, 0. And we need to replace the X column with this constant column. So let's replace the X column and let's find the determinant. Okay, so that's 5, 8, 7. Let's do the same thing. 5 times 1 times 0 is still 0. 1 times 1 times 7 is now 7. 4 times 8 times 5 is 32 times 5, or actually let's do 4 times negative 5 is negative 20, times 8 is negative 160. So if you want to pause this and do these calculations a different way, you can. But I'm going to go the opposite direction now. 4 times 1 times 7 is 28. 1 times negative 5 times 5 is negative 25. And then 0 times anything is 0. So 7 plus a negative 160 is negative 153 minus a positive 3. So we've got negative 156. So that's what X is equal to, negative 156. So negative 156 divided by a negative 26, this is actually going to be equal to 5, a positive 5. So the X value for this equation is positive, oh I'm sorry, not 5. Is it 5? No, it's 6. It's 6. So the X value for this is going to be 6. So that's really handy. I didn't have to solve for any of the other things, any of the other variables, just X. Okay, so I'm going to solve for another variable on this one and a couple of variables on this one in the extra help video. Alright, now let's move on from Cramer's rule, and we're going to talk about an augmented matrix. So an augmented matrix is really similar to when we wrote out the coefficient matrix, oops, that's 4, 0, times the variable matrix times the constant matrix. But this variable matrix doesn't really give us a lot of information. We know that they are variables and we can write down which ones. But what an augmented matrix does is it takes the same thing and it just combines it into one matrix. And you can write a vertical bar here to help you distinguish between where the equal sign is. But I just wrote those 3 numbers in the top row and the other 3 numbers right here in the bottom row. And this is an augmented matrix. That's what it's called, because augmented means like to combine, to put together. So I put these 2 matrices together in one. So I want you to pause the video and try and write this one out. And you should have written 1, negative 5, 15, 3, 3, 3. And I'll do this one in an extra help video. Okay, so then we're going to go the opposite direction. When you already have an augmented matrix writing the system of equations, well, this is going to be 6x plus 0y's equals 3, and then 1x plus 1y equals negative 5. So I could just write this 6x equals 3 and x plus y equals negative 5. Also, I didn't have to choose x and y, so nowhere in here are there variables, so I could pick any variables I want. I could call this a and b, and then this would be 6a over a plus b. I could call it anything that I want, any 2 variables. Okay, so now let's actually solve an augmented matrix. So the goal of an augmented matrix is to get something that looks like this. You have the identity on one side, and then on the other side you have something like, let's say, 2, 6. Okay? In this case, what this would mean, this is xy. if we had 1, 0, 0, 1 times xy is equal to 2, 6, then this is the same thing as saying xy equals 2, 6, because the identity times any matrix is just the same thing as that matrix. As an exercise, you could multiply this out and you could see that you would just get xy. But writing that is the equivalent of writing this, so x equals 2, y equals 6. So if we solve an augmented matrix to where it has the identity here on the left, then we found our solutions. So there's a couple rules with manipulating augmented matrices, and we're going to use those 3 rules repeatedly. The first rule is that you can multiply any row by any number. So just like I could take this equation and I could multiply the whole thing by 2, 2x plus 4y equals negative 2. This is still equal. I could do the same thing with the corresponding row in an augmented matrix. So this is my augmented matrix. I could multiply this row by 2, and so I could write 2, 4, negative 2. That's a legal matrix operation. Okay, so I can multiply or divide by any number to any row. The next rule is that I can add any 2 rows together. So I could say 2 plus 2 is 4, 4 plus 5 is 9, and negative 2 plus negative 4 is negative 6. This row would be an equation would be equal also. So it's kind of like when we do elimination. When you do elimination, you add these 2 rows together, and then you have an equation. And we know that this is still true because we added the stuff on the left side and we added the stuff on the right side. Since these things are equal, since x plus 2y is equal to negative 1, if I add x plus 2y to the left side and I add negative 1 to the right side, I've added the same amount to both sides, so we still have an equation, something that is equal. And then the other thing is, the order that I write these in doesn't matter. I could write 2x plus 5y equals negative 4, and I could write x plus 2y equals negative 1. That's swapping these 2 rows. It doesn't matter what order I put them in. So that's also true with an augmented matrix. So with an augmented matrix, 1, 2, negative 1, 2, 5, negative 4, I can switch these 2 rows and it's fine. I can multiply a row by anything, and I can add 2 rows. So, and you can do a combination of those. So, for example, I could add 1 plus 2 and get 3, 2 plus 5 is 7, negative 1 plus negative 4 is negative 5, and then I could swap. Here's another row that I can use, and I still have an equal system of equations. I can swap this out for any row. So I could come up here and say, I'm going to use those numbers instead of the ones that were there. 3, 7, negative 5. And that's perfectly fine. We still have an equal system of equations. I haven't changed the values of x and y. I did things that all work. So what we're going to do is we're going to take those 3 rules. So I'm going to write back the original one. That was 1, 2, negative 1. And we're going to try and make the identity over here. So the strategy here is really similar to elimination. We want to get opposite coefficients here or here to get a 0 in that place. So I would want this number to be negative 5, because then I could just add them together and I would have a 0 there. But it's not, so I would need to change it. This one's actually going to be easier. If this one was a positive 2 and this was a negative 2 and I added them together, I would have a 0. So that's actually what I'm going to do. And I'll show you, after you do a few of these, you'll start to kind of get the strategy behind it. But I'm going to multiply this row by negative 2. So that would make this negative 2, this would be negative 4, and this would be positive 2 if I multiplied that entire row by negative 2. Okay. Now I have negative 2, negative 4, 2. I'm going to add these 2 rows together. Actually, you know what? I'm going to save my original row, and I'm going to write it over here on the side. Multiplied by 2, it's negative 2, negative 4, 2, if I multiply this whole thing by negative 2. Now I'm going to take this row and I'm going to add it to the bottom row, 2, 5, negative 4. Adding 2 rows is a perfectly legal operation also, and so I get 0, 1, negative 2. 0, 1, negative 2. Now if I replace this bottom row was 0, 1, negative 2 with that row. Remember, replacing swapping rows is also legal. I've almost got the identity. I've got 0 and 1 here. That was really nice that I got that straight off. Now, I need to make this row here have 1, 0. So I need to make this 2 a 0. And the way I can do that is I'm going to take this bottom row here and I'm going to multiply it by negative 2, and I get 0, negative 2, negative 2, and now it has the opposite of that 2. So if I add these two rows together, the top row and this new row that I've created, if I add them together I get 1, 0, negative 3. So now I can replace this top row with 1, 0, negative 3, and I have the identity here, and then my solution is what's over here. Let's check negative 3, negative 2 to see if that works. So negative 3 for x, negative 2 for y, does that equal negative 1? Negative 3 plus negative 4 does not equal negative 1. Ooh, so I made a mistake. This should have been a positive 4 if I multiplied everything by negative 2, which would have given me 1, 0, positive 3. So this should be positive 3 here. And so I made another mistake. Positive 3 plus negative 4 is negative 1. Let's see if it works here. 2 times 3 plus 5 times negative 2 is equal to 6 plus negative 10, which does equal negative 4. So now it works in both. Here are our solutions. So I'm going to do one more example. I'm going to write this as an augmented matrix first. And then I'm going to try and get 0, 1, or 1, 0, 0, 1. So I want this to be 0. If I want this to be 0, I need to add this to something that has the opposite coefficient. These are already almost the same, so what I'm going to do is I'm going to multiply this bottom row by negative 1, and that will give me 1, negative 1, negative 20, and I'm going to add that to the top row, 1, 1, negative 10. And that will give me 2, 0, negative 30. So here, now I've got that 0 there that I wanted. I want this to be a 1, and it's not a 1, so I can make it a 1. Remember, you can multiply or divide any row by any number, so I'm going to take this row and I'm going to divide it all by 2. If I divide everything, or I could multiply it by 1/2, same thing. 1/2 times 2 gives me 1. 1/2 times 0 gives me 0. 1/2 times negative 30 is negative 15. So now I have 1, 0, and that's what I really want. So I'm going to replace this top row with 1, 0, negative 15. 1, 0, negative 15. Alright, now this bottom row, I really need this to be a 0 right here. And these are already opposite coefficients, so if I just add these two rows together, 1, 0, negative 15 with negative 1, 1, positive 20, then I get 0, 1, 5. I have 0 and 1, which is what I want, and I can just replace this row with 0, 1, 5. 0, 1, 5. So now I have my solutions. X equals negative 15, y equals 5. Let's check it to make sure it works. Negative 15 plus 5 does equal negative 10. Negative 15 plus 5 does equal 20. So it works in both cases. And that's augmented matrices. Really useful. When you have a problem like this, it's a really big problem, and it would take a long time to solve, but you can solve it with an augmented matrix. But the nice thing is you can also solve it in one step with a calculator. So if you plug this into your calculator or some statistical software as a 3x4 matrix, because there's 1, 2, 3 rows and 1, 2, 3, 4 columns, you don't even really need this to do augmented matrices. We just write it so that we can remember where the solutions are. But this is a 3x4 matrix. You can plug that into your calculator and tell it to give you the identity here, and it'll solve it and spit back out 1, 0, 0, 0, 1, 0, 0, 0, 1, the identity, and then the numbers that are over here, like 6, 10, negative 1, that's not the solution to this problem. will be the answer. So it'll give you this matrix. We'll talk about that in class. But this is the type of thing also that it's fun to try and solve by hand. And we will have problems like this, and I'll put some of them on the test, but they'll be extra credit. You won't have to solve them by hand as an augmented matrix. And that's all for this lesson.